This is part 6 of solving rational equations. Remember, a rational equation is an equation that has some fractions. And we're going to start working with proportions. So a rational equation that is a proportion has this form: A over B equals C over D. In other words, it's just one fraction is equal to another fraction. Now, when we were solving equations like this, we multiply both sides by the least common denominator. So in this case, the least common denominator would be B times D. So what happens if you multiply both sides of the equation by B times D? Well, the left-hand side, the B's cancel, and the right-hand side, the D's cancel. So I end up getting AD equals C times B. I'm going to write that as BC. Well, what is that really? What's really going on is, if you look at your original proportion right here, you multiply A times D, right? And that gives you the same thing as multiplying B times C. So that's the idea. If you have something in this form that's a fraction, one fraction equaling another fraction, notice it doesn't say plus something else or minus something else, two simple fractions on each side, you can multiply the numerator of one times the denominator of the other, and that's the same as the numerator of the other times the denominator of the first, for instance. We call this cross multiplication. Let's solve this rational equation using the method I just showed you, because it is a proportion. By the way, there's more than one way to solve this, but we're going to use proportions. So I have a fraction equaling a fraction. So I can multiply the numerator of 1 by the denominator other. So I'm going to do 6 times x plus 3. Oops. 6 times x plus 3. And that's going to be the same thing as multiplying the 12 times the 5. Okay, so let's finish this. 6x plus 18 equals 60. Subtract 18 from both sides. Six x is 42. Divide both sides by 6, and we have x equals 7. So let's see if that checks. So I'm going to move this over a little bit. Okay, so we're going to take the original problem to check it. The original problem was x plus 3 over 12 equals 5, 6. And we're just going to plug in 7 for x. All right, so on the left-hand side, that gives me 10 twelfths, which reduces to 5, 6. Okay, and on the right-hand side, there's no variable, so we just write the number down again. So 10 is a so 7 is a solution. So this is correct, and you can put that in braces to show the solution set. So that's one way of solving this problem. Let's do the problem again and analyze it just slightly differently. All right, so here's the problem. X plus 3 over 12 equals 5, 6, and then we got x equals 7. Let's see how somebody might have reasoned this out without using algebra. These are just equivalent fractions. 5 sixths is the same as x plus 3 over 12. And you might say, well, to get that denominator of 12, somebody might just reason it out, say, well, I would have to multiply the top and bottom by 2. Does that make sense? So we're saying x plus 3 over 12 is the same thing as 10 twelfths. So somebody might just say, oh, that means x plus 3, the numerator must actually end up being 12. So you get the answer using a completely different train of thought. Checking would be exactly the same. I would still get my answer of 7. So you can use proportions to solve it, but that doesn't mean that's the only way you can get it. You might reason it out slightly differently. All right, here's another problem. Now this one will be harder to do just kind of by eyeballing it and trying to make trying to make equivalent fractions like in the example I just did. So this is a natural one for just going ahead and doing proportions because you do have one fraction equaling another fraction. So what we could do here is multiply one numerator by one of the denominators. It doesn't matter which one you do first. So how about 5 times x plus 2? And then I'm going to multiply the other numerator by the other denominator. So I'm going to do 3 times x plus 1. Okay? And then we're just going to simplify each side to see what kind of an equation this is. And this is a linear equation because I don't have any x squared terms, etc. So I just want to get the variables on one side, constants on the other. So let's subtract 3x from both sides so that the variables will be over here on the left, 2x. And if there's 2x on this side, how about subtracting 10 from both sides so that I have my constants on my right. All right, the last thing to do would be just divide both sides by 2. This is the easy part of the problem, solving it. And I get x equals negative 7/2. All right, now it's extremely important to check any equation once you solve it, but especially rational equations and proportions to make sure that you don't get a 0 in the denominator or any other strange things happen. So let's see, let's just move this over a little bit to the left. And let's go ahead and check. So we're going to write down the original problem, x plus 1 over x plus 2 equals 5/3. Now in this case, you know what? It's going to be harder checking this problem than actually solving the original problem. So we're going to put in negative 7/2 for x. All right, now we have this complex fraction. So what we're going to do is add the numerators and add what's in the numerator, but you have to get a common denominator. So you have to think of that as negative 7/2 plus plus 2/2 all over negative 7/2 plus 4/2. Okay, so in the numerator I'm going to have negative 5/2, and I'm dividing by what's in the denominator. That's going to be negative 3/2. And now I need to multiply by the reciprocal. So negative 5/2 divided by negative 3/2 is negative 5/2 times negative 2/3. Why is that, by the way? It's because I'm just multiplying the numerator and denominator by negative 2/3. So you'd have a 1 in the denominator. So if you weren't used to that, multiplying by the reciprocal. So what happens here? You get the negatives to cancel, the 2's to cancel, you should end up with 5/3. So your final answer on the left is 5/3. Right, what was the right-hand side? Ah, thank goodness, it was 5/3. So there we go. This side is also 5/3. So if we sort of like follow this down, it checks. So this is correct. So if I use my solution set, I can write that in braces, and we have negative 7/2. So this is an example of solving a proportion using the idea of A over B equals C over D is A times D equals B times C. Here's a problem for you to try, and you can use proportions. So you can put the video on pause and then try it. And I'll be solving this, showing all the steps on the next video. But if you did do it, hopefully you got that the solution was 15. All right, so you can go on to the next video if you want to see the steps, and I'll be doing some more problems on proportions.